Hello, Brian. It is Sunday, October 27th, and I have finally uh, accumulated the time necessary to make a video. I understand that that is a bad excuse because it only takes me about 10 minutes and I don't edit them at all. So, sorry about that. I'm not good with these sort of things. Deadlines, as it were. But, apparently today we will be talking about space. The final frontier. Sorry. Yeah, I do know a bit about space. Um, Not a whole lot, for there's a lot to be known. Because, as it turns out, space is the majority of what is. Uh, and by that I mean what we know as, you know, what is, which is we generally think of as Earth, is essentially nothing when it's compared to the vastness that exists. But on the bright side, most of that vastness, or essentially all of it, is completely hazardous to humans, and in my opinion, should be explored with extreme caution. So yeah, you wanted to talk about, you wanted me to tell you about some cool stuff in space, or maybe the coolest stuff in space. Well, I have to start with the remarkableness that is Earth, because we here on Earth are pretty much the perfect hotspot for hydrogen-based life, which is the only kind of life that we can currently imagine. Although, if I recall, somebody has talked about ammonia-based ecology too, but since we cannot replicate that on Earth, we cannot imagine what it's like. But basically, other planets and other solar systems, life on Earth requires very strict conditions. Like, we don't think of it like that. We're like, oh, well, some fish can live in extremely cold, salty water, and, some bacteria lives in hot springs and down at the, uh, deep sea vents and in freezing cold temperatures. But that's all a very narrow range uh, of stuff. Uh, like other planets in our solar system not only have a temperature range that is more or less insane. For instance, the hottest body in our solar system, Venus, gets up to something like 800 degrees Fahrenheit, which is insane. Others are so cold that gases, what you'd think of as gases, I forget which planet this is because I decided not to do research for this, because that would be like cheating. But there are planets in our solar system where they have oceans, but because it's so cold, these oceans are made of what we commonly think of as gas. Like, there are oceans of hydrogen and whatnot, like a gas, but it's, a liquid because it's so cold, which is insane and would be insanely poisonous and awful and toxic and unimaginable to humans. So, I remember you mentioned something about colonizing Mars, which would be really, really mega difficult. Because not only do these planets not have atmosphere, I mean, Mars is a very thin atmosphere, but they don't have correct atmospheric pressure or gravity, the right amount of gravity. They all have gravity. So no matter what, we're going to be in pressure suits and we won't be able to grow anything. It's possible, but it's all quite obnoxious. Cool stuff. Well, fun fact, the vacuum that we consider to be space is actually not a vacuum. There are particles in space, but they are so dispersed that it operates like a vacuum. I know that that's an arbitrary distinction, but I was fascinated to learn that. Well, we all know of black holes, which are baffling from a physics perspective. I don't think anybody appreciates the fact that the idea of an infinitely massive object, it doesn't really jive with our understanding of physics, but it happens, apparently. Yeah, black holes are when a sun, uh, uh, I think a dwarf star or a giant or something, a specific kind of star dies and collapses in on itself. Stars are extremely massive, which is it's insane. All planetary objects are massive, but stars are extremely massive, and somehow the energy in it gets converted to mass, and it collapses in on itself, and it creates an infinitely massive object. So much that light cannot even escape, and we don't experience mass on this scale, so that we really understand the way that it can influence forces. Like, we don't think of mass as a force, we just kind of think of it as like a thing, like this is massive, I'm massive. But like, when you get mass accumulated on that scale, mass affects time, mass can bend light and space and all sorts of crazy shit. Yeah, that's why black holes are black, because light cannot escape from it. And apparently, if you could orbit around a black hole, which is theoretically possible if you were going fast enough, you could orbit around a black hole. The mass, I hate my floor. The mass on top of the speed that you would be going, time would essentially not affect you. And I don't mean this in the classical sense of you would not age. I mean you would age normally, but the world around you would go so fast that, you know, it wouldn't really be quite safe to do this, because by the time you decided to escape, the universe would be so far into the future that it would be unrecognizable to you. It's very difficult and very weird to think about forward time travel in this way, but it does happen that way. Well, space, yeah. Humanity is not quite ready for space, in my opinion. And I don't think that space will really be an option for another century at least. And that's assuming we don't have a major oil crisis or economic collapse. Assuming that technology can advance at a reasonable pace, I don't think that even intrasolar colonization. By that I mean the moon, Mars. Venus is kind of ridiculous, but moons and whatnot, I don't think that's possible within the next century. Maybe 21.5. I don't think. Basically, I think that if anyone, it would be like our great grandchildren that will ever go to another planet for fun, because it's just not. It's not quite on our scientific radar right now. There's so much radiation and so many hurdles to get over, and it's not cost effective. So, sorry if that's disappointing. I hope you're doing well. I will presumably see you over Thanksgiving, hopefully. Alright, I will see you next week. So I forgot to do a topic for next week. I did a little bit of thinking, and I decided to ask Brian, what is your favorite book ever, and why?